So all of this section 3.3 is on function notation. Function notation usually looks like this. Function f is, we'll just say mx plus b right now. Now, one more time. What did I tell you f of x is the same as? Okay. So this is the same as saying y equals mx plus b. And it's just a different way to write the same thing. So when we have a function, we can make a table, and we can say when x is 0, y is this. So let's say we have this function, f of x is 1/2 x plus 3, or y equals 1/2 x plus 3. So remember, we can put a 0 where x is, and say half of 0. What's half of 0? Alright, plus 3. Or we can say f of 0 equals 1/2 times 0 plus 3. So f of 0 equals 3. And you can see we're just doing exactly the same thing, aren't we? Is there any difference? Just the way it looks a little bit, right? When I look at this function right here, what is its name?
F of x.
Yeah, f, function f. Okay, so that's what we call is just function f. And usually for functions we use f of x, g of x, h of x. These are the most common, but you can use whatever. And in a real problem, you're going to use some letter that makes sense. You know, if you're talking about distance or time or speed or color of hair or something like that, use a variable that makes some kind of sense. What do I want to see on the assignment? Well, when they give you a function, 2/3 x minus 5, and they say evaluate it when for h of x equals 7, or find h of 7, let's say. You know, I don't really care if you write down the original problem, but I do want to see that you're writing it out. Is it okay to use a calculator?
Yeah.
Sure, yeah. So, you know, h of 7, where's my calculator? Where's my calculator? It's kind of nice to have the fraction key on here, isn't it? Especially when we're doing 2/3 times 7. So fraction 3 times 7, subtract 5. Now, you need to be aware, it's actually going to take the fraction 2/3 times 7 first, and then subtract 5 from that. So the calculator will do things in the correct order, and that is -1/3. And I expect to see that on your paper. Now, you don't have to do it all by hand. You don't have to say, well, that's 14/3 minus 5, and that'd be 15/3, and then I can subtract. Wouldn't be that hard, though. But I expect to see that you plugged it in and made it work, okay? Now, graphing a linear function. They're going to ask you to graph a linear function, and sometimes they might just say graph it and not really say much about it. Other times they're going to give you a table, and they always draw their tables like this, okay? And they're going to ask you to put specific numbers in and make a table and then graph those points and draw the line. Is that difficult? Shannon, what do you say? Good? Bad? Okay, we're good. So I really would love to see that you're, maybe not the 0. Can we do it without plugging the 0 in? What do we get? 2. If we put the 4 in, what do we get? Or sorry, if we put the 2 in, what do we get? 4 plus 2? Put a negative 2 in. Put a 4 in. I'm glad one of you knows. Can we graph those 4 points? Make sure they line up, right? If your points look like this, right? We know something's going on. Make sure you go back and take a look at them a little more closely. If it just says graph it, and you can say, well, the y-intercept is 2 and the slope is up 2 over 1, great. Okay, we've already talked about that. That's something you can do. Make it happen. Turn to page 124. I'll get my glasses. See the helicopter? Let's take a look at that graph. First of all, I want you to notice about that graph, it's only the first quadrant. Why doesn't it show the second and third and fourth quadrant? Why not? Okay, so we're not going to go back negative hours, right? And are we going to go back negative distance? No? Okay, so save yourself some time, draw the part of the graph that makes sense, okay? So what is this thing saying, this graph? At time 0, where are you? 300, what do you mean 300? 300 miles up in the air? Down in the water? Away from home? What's going on?
Probably from your destination.
From the destination. From where you're trying to go. You're 300 miles away. Okay. And then what's happening as time goes on? As the hours are going on?
You keep on.
Okay, you're getting closer. So the distance you are is getting smaller, right? So do you see why the slope here is negative? Right? We have negative slope. Okay, we have a negative rate of change. And as you read through this problem, the two things you need to be looking for are a rate of change and then a start point. A start point or an initial amount. Okay? So that you can write an equation, y equals mx plus b. You are looking for a starting point, that's your y-intercept, okay? And you're looking for a rate of change. Okay? Now, the rate of change, it's easy because a rate isn't just a number like 300 miles or 16 scooters or 3 redheads, okay? A rate is something per something. Miles per hour, feet per second, students per class. A rate is easy to recognize, okay? So let's read through this example number 5. Nikai, start reading. Top of page 124, example 5. You're right there.
The graph shows the number of miles the helicopter is from its destination. After X hours on its first flight. On its second flight, the helicopter travels 50 miles further and increases its speed by 25 miles per hour. The function of x equals 350 minus 1.5x.
Okay, hold on a minute. So the first flight, how far were they from the destination? How far were they in the graph on the first one? 300. How far are they on the second one? So that initial distance is changed, right? And the rate of change is changing from 100 miles per hour to, why is it negative 125, guys? Okay, I want you to look at this function. What do you think of that one? What if you said, I need to travel this far and I'm going this fast, and you thought as of the distance you had to travel as a negative and how fast you're going as a positive? Would that work too? It would work, wouldn't it? Okay? They're doing it this way. Okay, so the distance we have to go is 350 miles, and we're cutting that distance down each hour. So they're looking at our rate of change as a negative. Does that work for everyone? Okay. Okay. Keep going, Nikai.
For FX,
Just read the last line there.
which flight takes less time?
Which flight takes less time? So, how much time does it take? How long did the first one take?
3 hours.
3 hours. Okay, so let me show you that function. First flight, f of x, was 300 miles minus 100 miles per hour. Okay? And if you want to know when are we there, when is this distance right here going to be a 0, what do I put right there? Some of you act like you didn't know what I was talking about. Let's try that again. Okay, this is my distance from home. It's 300 miles minus 100 miles every hour. I want to know when I'm there. I want to know when this number is a 0. How do I, yeah, but how do I find that out? Put a 0 there. There you go. Solve it. Okay, can we solve this? What do you want to do? You want to subtract 300 from both sides or add 100x to both sides? Who says subtract 300 from both sides? Who says add 100x to both sides? All right, you guys won. So we're going to subtract 300 from both sides. And then we don't have a choice. We have to divide by this. Now this one's easy. I understand you guys can look at it and say, oh, it's 3. Right? But the next one, it gets a little more interesting. I want to make this one s of x. So like second flight, is that okay? And we want to know how much time this one's going to take. In other words, when does this number equal 0? And you might not be able to look at the graph and tell exactly what it is. If it, like in this case, it looks like it's exactly on 3 hours, but if you just looked at the graph, could it be 3 hours and 5 minutes? You get the idea? Okay. So let's solve this one. What do you want to do to both sides? All right. So I'm going to do that. Well, I know this answer is positive. $2.8. So even though they're further away to start with, it takes a little less time to get there, doesn't it? Okay. This is how a function works. So now I have a question for you all. I don't care where you do this. You can do it on where you're going to do the assignment today. Let's say third flight, t of x, looks like this. Bad weather, can only go 75 miles an hour, but we only have to go 250 miles. How long is that going to take? How long before we're there? Write it down. Put 0 where it goes. Solve it. Use your calculator if you need to. How long does it take? Who has an answer? What do you got? Oh. Dustin, what do you got?
Well, I didn't have a calculator to divide, but I got 250 over negative 75.
Okay, so you got negative 250 over negative 75, whatever that is. Okay. What do you got? 3.33333. Can I just say it and a third? Would that be okay with you guys? 3 1/3 hours. Why is any of this important? What does it matter? How much fuel do you have on a helicopter? Can you just fly forever?
No. So you have to measure how much you get.
Okay. Can you just stop anywhere and get fuel? No. So, let's say coast. Okay. Here's a ship out here in the ocean. Here's you in your helicopter base. This ship has a guy on it that's hurt really bad. And they are headed to this harbor, which is the only place there's a town where he can get some help. But it's going to take them about 2.5 days on this ship to get from here to here. So the guy's not going to live. They're going, I mean, they can only go like 20 miles an hour. Okay? So they call you, you're the Coast Guard helicopter, and you're going to go get the guy off the ship and then take him either back here where there's a hospital or here, whatever's closer. Okay? So first of all, you take off. Is that where you fly right to them? What are they doing while you're flying to them? They're moving. Where are they going to be when you get to it? If you fly to here, where are they going to be when you get here?
Like not there.
Yeah, not there. They're going to be up the road a ways, right? I noticed when my kids were little and I was driving a tractor and they would come out to get in the tractor with me, they would walk dead straight toward the tractor. Well, what was I doing?
Driving.
Yeah, so it would look like this. Here I am driving up the road bailing, and they'd start walking dead at me, and I'd be driving along, and then pretty soon they'd be like this, and then I'd be up here and they'd be behind me, and I'd just keep going, make them run. After a while, what happened?
They started taking angles.
Yeah, they started figuring out, just walk to the end of the row and wait for me to get there, right? Okay, so this. You want to fly where they're going to be so that you get there at the same time. So you got to know how fast they're going and what heading they're headed at, and then you need to know how fast you're going and figure out where you're going to meet. And not just kind of. If it's stormy, if anything, how far you can't even see very far. You've got to be there. And then you've got to get them off, and then you've got to get them to the wherever they got to go, there or back home. And you've only got so many hours of flight time. And when you're out of fuel over the ocean in a helicopter, that would be scary, wouldn't it?
Prepare to go swimming.
One of the scariest thoughts I ever had in my life, flying to Hawaii, and we've been flying from Los Angeles for 3 hours, and I looked down and just looked at the ocean, and we had 3 hours left to fly before we got to Hawaii.
Well, that's
That was kind of a scary thought for me. I hope someone remembered to fill her up.
Wait, you flew there in a
Yeah, and
No, in an airplane. I don't even think there's a helicopter that can fly from from California to Hawaii.
But
Sorry, that was a horrible story.
and the scarier part about that is like it's not your responsibility. Like,
Exactly, you have to trust someone else to do it.
They have-
Which probably is good because they're professionals and I probably would forget to fill it up.
But sometimes everyone
Yeah.
They
gets
have
something.
control over your life.
They do have control of your life. So you kind of hope that, I don't know, they paid attention during their schooling when they were learning how to take care of a plane, right?
Scariest.
So anyway, think about what's going on here. It's just an initial distance, and how fast can we go? Okay, and what's our fuel usage? How much are we using per hour? Does that sound like a rate of change? Gallons per hour? That's a slope. Okay, your distance away, that's an initial amount. That's what we're talking about here. As you do the assignment today, please carefully read the instructions. If you carefully read the instructions, it's going to save you a lot of time. All right? You're going to think that you have to do a lot more if you don't carefully read the instructions. For example, look at number 3, though. Evaluate the function when x is -2, 0, and 5. Do you understand that you've got to put -2 in, you've got to put 0 in, and you've got to put 5 in? And that means I want to see f of -2 equals -2 plus 6. So f of -2 equals 4. F of 0 equals 0 plus 6. So f of 0 equals 6. And, f of 5 equals 5 plus 6.
So that's like 3 parts of each one.
Well, not each one, but in this one it is. And I really want to see all of that. That's one problem. I'm only giving you like 25 problems. That's one problem. I just did it in 20 seconds, maybe.
Will number 3
Okay.
be one of them?
Is number what?
Will number 3 be one of the ones that we have to do?
Oh, of course not.
Ah, dang. You should have shown us an example like number 4 or something.
Yeah. But then I would be nice and we wouldn't want that.
That's
Okay, here we go.